Hi, my name is Brian, and today I will be presenting our work on atrial fibrillation detection in the ICU using weakly labeled data. So why atrial fibrillation and why the ICU? Well, estimates vary, but it is the most common arrhythmia found in an ICU context. Moreover, it's associated with many adverse outcomes such as stroke and heart failure. Because of this, there has been extensive research in applying machine learning and in particular deep learning techniques for detecting this kind of arrhythmia. The ICU is an excellent data source here because it is passively collecting large amounts of high-frequency physiological data from the bedside. However, most of this data is not labeled. Our approach to address this labeling problem has four parts. Firstly, we gather ECG telemetry data from the ICU and annotate only a small subset of it for evaluation purposes. We then use a deep CNN model trained on an existing public dataset and apply it to our unlabeled data to generate weak label predictions. These weak labels are then used along with weakly supervised learning methods to train models end-to-end on only our data. Lastly, we also try fine-tuning the weakly supervised models on a subset of our label data to compare using only weak labels and using weak labels with some ground truth labels. With this approach, we find that adding a large quantity of weakly labeled data can dramatically improve performance over only using a smaller set of ground truth labels. However, when we compare this against the performance of the label generation model itself, we do not find there to be a significant performance increase. When we looked into the estimated percentage of weak labels in the dataset, we found it to be much lower than the baseline noise levels used in previous studies that applied similar techniques to different data modalities, such as images. And lastly, we found, surprisingly, that fine-tuning actually results in worse performance when using weak labels. So in conclusion, many healthcare domains still lack a wealth of clean and labeled in-house data for developing ML applications. Training with weakly labeled data can dramatically improve model performance when ground truth labels are limited. And weakly supervised learning techniques have promise in this area, but will depend on the amount of real-world noise in the dataset and only provide marginal returns when there is a limited amount of noise. And with that, thank you for your time.